Hello everyone, and thank you for joining me today as we learn about the first-hand experiences of two researchers who are currently using the VSP-P1 Nanostructured Material Printer. The first researcher that we'll be talking to today is Merlin Palmar. Welcome. Thank you for joining us.
Hello, thank you for having me.
Thank you for joining. First of all, could you please introduce yourself and tell us something about the research that you're currently doing?
Sure. I am Merlin. I am from Estonia and I'm currently doing Masters in Biomedical Engineering in the Delft University of Technology. I am working in the Department of Bioelectronics and I am working on biosensors, trying to enhance their electrical characteristics.
So, VS Particle has a growing presence in a wide range of fields, especially fields that are using nanoparticles as building blocks for materials research. This has brought us into contact with a wide range of researchers across the scientific spectrum, and I really wanted to know what it is about the materials that you make that influences society and how do they move science forward?
Okay. So I am not exactly creating new materials, but I'm using the nanoparticles as coating on my device. So nanoparticles have shown to reduce the impedance of neural electrodes, and we want to reduce the impedance to have lower signal-to-noise ratio. And with that, we can also make the electrodes smaller. So in the end, we want small devices to have less tissue damage when they are implanted in your body.
Okay, so this is then trying to optimize the production of these biosensors.
Yes,
then.
exactly. So I'm trying to enhance the electrical characteristics of the device.
Now, something that we've also known at VS Particle is that a lot of researchers have been using well-established techniques within their field. And this is really a challenge for us to then try to break through into fields that have well-established techniques, because a lot of researchers are a bit apprehensive to trying out a new or novel way to prepare their materials. So have you been using conventional techniques to prepare these biosensors? What kind of techniques have you been using up until now?
Mm-hmm. So I personally haven't used, but usually to create nanoparticles on the surface, electrode deposition is used, which is a wet chemical process, which now is not good for the implants, since the design of the implants is moving towards flexible forms, which means usually soft polymers are used. Mm-hmm. And wet chemical processes are not good for this because the vapors can penetrate through the polymers. So now with the VS particle technology, with the spark ablation technology, we can, this is a dry process, so we can print also on the devices with polymers and don't need any further processing steps.
Okay, so in essence then you're able to prepare everything in a single step rather than a multi-step process.
Exactly.
Because these wet chemical processes then, I mean, there's the initial deposition, and what kind of post-processing of these polymers do you then still need to do?
Yeah, so that's the problem, because you shouldn't do any wet chemical processes, because if the vapors go through the polymer to your electronics, they can create short circuits and ruin the electronics inside the device.
Okay. So within your group, you're at the forefront of using new techniques to prepare biosensors. Now, in the last few months, during your master project, you've been using the VSP-P1 Nanostructured Material Printer to prepare your biosensors. Could you give us an idea of the steps that you take when you prepare your materials?
Mm-hmm. So first of all, we need to figure out which materials we want to print. And in my case, we also wanted to print less than a monolayer, so just kind of sprinkle the nanoparticles on top. And for that, we had a lot of optimization to do. So using different parameters, what kind of densities can I get? So that took a bit of time, but it wasn't too much hassle, and we could do it very easily with the VSP nano printer. Because you can just change all the parameters really fast, and it was easy to optimize.
Okay, because essentially then you just place your substrate or your I guess it's a biosensor chip.
Yes, it's a substrate.
Okay, so you place your substrate into the printer, and it's computer-based from then on?
Yes, so usually we also, we need to write the code for which patterns we want. In my case, it's very simple because I just make a dot on the area where I want it with a short period of time. And yeah, then I just press play and the nanoparticles appear.
Okay, and it's the same then if you were to replace your substrate, you can just use the same code to prepare the same substrate, I
Yes,
guess.
exactly.
Okay.
When I already have figured out all the parameters, the next samples are very easy to make.
So Merlin, within your research, I guess you also want to vary some of the parameters or features of the biosensors that you're preparing. What kind of features are you looking at varying, and how are you able to achieve this with the printer?
Mm-hmm. Like I mentioned before, I want to print less than a monolayer of nanoparticles, and I want to use different densities on the surface. So yes, for that I just need to change the speed, the time of the printing, or lower the frequency of which the sparks are created between the electrodes, so that reduces the amount of the nanoparticles. And I can also change the size of the nanoparticles, so the size of the nanoparticles also matters when we are looking at the surface area of the electrode. So changing the flow of the gas flow that goes between the electrodes, we can change the size of the nanoparticles also.
Yeah, okay. And now that you've had some experience with this, because you've been working with our system for a couple of months, do you have any ideas on new materials that you're looking at preparing, or new biosensors that you're thinking of making?
So we are now trying different metals on the electrode to see how much they are changing the electrical characteristics. I'm sorry, I cannot discuss that further. We are still researching that.
Okay, but you are able to then try out different metals?
Yes, that's true.
Okay, and how much difficulty do you have with then varying the metals?
So to change the metal, just need to change the electrodes inside the machine. It's not a difficult process. Just need to scroll out the electrode holders and then put them back in.
Okay.
Change the electrodes and then put them back in.
Okay. That sounds convenient enough.
Yes.
Okay. Then I think it's also just interesting to know, you've been a master's student for a couple of months. You've been working with our system for a couple of months. But how is it that you came across VSP and learned about us?
So I'm doing my thesis project in the Department of Bioelectronics and Electrical Components, Technology and Materials Department. And they have a collaboration with VS Particle. So VS Particle lent us one of the generators, and which is in our clean room right now, so we can use it.
As a user of the VSP-P1, what steps do you take to prepare your samples?
Okay, when I have the devices ready for nanoparticles, and I go to the nanoprinter, I flush it with gas so that it wouldn't be under vacuum. I open the door and I put my samples in, and I put the chamber under vacuum again. Then I just set the parameters on the computer, the flow and the current, which then determines how frequently the spark is created between the electrodes. And then I set the trail where I want the printer nozzle to print, and start the nanoparticles. And after, I need to flush the chamber again to clean also the nanoparticles out of the chamber so that they wouldn't get in the air, and then take the samples out.
I think it seems like quite a clear explanation. Thank you very much, Merlin, for giving us the insights into your research and your experiences with the VSP-P1. I wish you all the success in the future with your research, and I hope to hear from you soon. Take care.
Thank you.